Hey mathematicians, that last video was getting kind of long, so I wanted to break it up into two videos. This is the second half with the real world examples, so let's jump into it. Larry, Camille, and Simone are keeping track of how far they walk each day. At the end of the week, they combined their distances and found that they had walked 34 miles in total. They also learned that Camille walked twice as far as Larry, and that Larry walked 2 more miles than Simone. How far did each person walk? So I've already done a little bit of writing to save myself some hassle. The first writing that I did was I assigned each of them a variable. Larry is X, Camille is Y, Simone is Z. And then I went ahead and I wrote out their equations as well. So we know that altogether they walked 34 miles. Additionally, we know that Camille, who is Y, walked twice as far as Larry, who is X. And then, of course, we have Larry, who walked 2 more miles than Simone. So I've got those 3 equations written out. Now, most of you want to hop right to that elimination, trying to line up your variables, see which one you can get rid of. However, the cool thing about this problem and what we should notice is that we already have 2 variables that are solved for. We have an X and we have a Y, which means we can right off the bat substitute these 2 equations into our first one in order to get rid of 2 variables. So that is the last step I've written down. However, you'll notice that I still have an X involved here, and it would be really nice if I could write this entire equation in terms of Z so that I could simplify it. Here's my trick. If I know that X is equal to Z plus 2, and Y is equal to 2 times X, I can replace the X in my Y term right here with Z plus 2, and that'll look like this. Z plus 2 times Z plus 2 plus Z equals 34. So I have effectively gotten rid of all X's and Y's in my equation. Why is this helpful? Well, let's simplify and see. We have 2Z plus 4 plus Z, and then Z plus 2. So now when we simplify, we have 4Z's plus 6 equals 34. Simplify down to 4Z equals 28, and I find that Z equals 7. Now, just using that substitution, I've already got one variable, and I didn't have to do any elimination. Now I can plug it back in. Let's solve for X. If X is Z plus 2 and Z is 7, that means that X is equal to 9. Okay, cool. Do the same thing. Let's plug it back into our original up here. 9 plus Y plus 7 equals 34. Move the 9 and the 7 over, and Y equals 18. I already have my 3, and I did no elimination whatsoever. Finally, we're going to put them in that coordinate. But if you want, and I usually do in terms of these real world problems, I usually go back up and assign who walked how many miles. So Larry walked 9 miles, Camille walked 18 miles, and Simone walked 7 miles. And if we actually read the problem over and we put those numbers back in, we do find that they work. So there's that one. Second real world example. A natural food store makes its own brand of trail mix out of dried apples, raisins, and peanuts. 1 pound of the mixture costs $3.18. It contains twice as much peanut by weight as apples. 1 pound of dried apples costs $4.48, a pound of raisins costs $2.40, and a pound of peanuts costs $3.44. How many ounces of each ingredient are contained in 1 pound of trail mix? Again, let's go ahead and start assigning variables. X will be my apples, Y will be my raisins, and Z will be the peanuts. And then, of course, I'm going to write out some other prices. It says 1 pound of apple costs $4.48. There are 16 ounces in a pound. So I'm going to find out, since we're talking in terms of ounces, how much these are per ounce. So 448 divided by that 16 is going to be 28 cents per ounce. And then I'm going to do it for raisins as well. Raisins is 240 divided by 16. I find that it's 15 cents per ounce. And then peanuts is $3.44 divided by 16, 21.5 cents per ounce. That way when I'm writing this problem, I'm not talking in terms of pounds. It's a little bit easier to work with. So it says 1 pound of the mixture, meaning when I add my apples, my raisins, and my peanuts, it's going to equal 1 pound or 16 ounces. It also says that it contains twice as much peanut by weight as apples. So my Z, my peanut, is going to equal 2 times however much weight there is for apples. The last piece of information I know is that 1 pound of the mixture costs $3.18. So when I multiply each of those prices, 28 cents per apples plus 15 cents for raisins plus that's 21.5 for peanuts, altogether it equals $3.18. Just like the last problem, I right off the bat notice that I have a variable that is already solved for. So what I'm going to do is I'm going to plug that into my top equation right here and my bottom equation. And when I do that, I'm going to already eliminate one of my variables. So I'm going to get the equation, let's write it down here, x plus y plus 2x equals 16. And then in my bottom equation, I get 0.28x plus 0.5y plus 0.215 times that 2, so 0.430. Let's double check that. I never trust my own mental math. Times 2, yep, 0.43. 43x equals 318. And then of course we simplify it to get 3x plus y equals 16 and 0.71x plus 0.15y equals 318. Now we're just going to do a little multiplication of both of these. I'm going to multiply this bottom one by 100, and then I'm going to multiply this one by 15. That'll get this number to be 15y, and then this top one, I'll actually multiply it by negative 15 so that they cancel out. So I end up getting negative 45x minus 15y equals negative 240. When I multiply the bottom by 100, I get 71x, positive 15y, 318. Now those two cancel out. We're good to go. I'm left with negative 26x equals negative 78. Solve for x. I get x equals 3. Oh, it'd be nice if you could see what I was doing. I apologize. From here, it's just the plug and chug back into what we know. Simple one to plug back into is this z. Let's get that right away. Z is 2x, so z is 6. Plug it back into this, the x and the z. I can't fit both of them on the screen, I apologize. But you'll see that y is 7. Final answer, 3, 7, 6. That's a lot of work. That's why I gave you an entire page to do it. I know that these word problems can be a little bit tricky to set up, and they can be even trickier to solve. So if you have any questions on these word problems or anything in the last video, please don't hesitate to ask.